Trigonometric functions can be used to model behavior that we see in the world around us. The following example is where we can use trigonometric functions to model the behavior of tides and the depth of water. Please take a second, pause the video, and read this question. Having read the question, you may have found the following pieces of information. The maximum occurs at 2 p.m. and that is 10 meters. The minimum occurs at 8:15 p.m. and the minimum depth is 1.2 meters. Note that it takes 6 1/4 hours to go from the maximum to the minimum. Right? Another way of writing that is 6.25 hours. If I was to sketch this as a function on a graph, I'm starting at the maximum right here, 10 meters. I go down to a minimum, which would be represented right there as 1.2 meters, and then I come back up. This over here, the maximum occurs at 2 p.m. or time is equal to 0. So that is your 2 p.m. So I can write a let statement. I can say let t equal to 0 represent 2 p.m. Therefore, the minimum, which occurs 6.25 hours later, is 6.25 or 8:15 p.m. It then goes back up to the maximum another 6 1/4 hours later, so that would occur at 12.5. This graph should look familiar to you. That is a cosine function. So I'm going to graph this using a cosine function. The first thing we're going to do is we're going to find the amplitude. And remember that A is equal to the absolute value of maximum minus minimum divided by 2. Oops, sorry, that should be an absolute value sign, not a bracket. 1 second. There we go. Okay, so then A is equal to 10 minus 1.2, all divided by 2, and that equals to 4.4. Okay, so A is equal to 4.4. Then if I want to find my C value, remember my C value is given as max plus min divided by 2. So C is equal to 10 plus 1.2 all over 2. And the C value is equal to 5.6. Okay. So if I'm using the cosine function and I'm starting at the maximum, that means there is no phase shift because the cosine function is already starting at its maximum. So D is equal to 0 since starting at a max. The last thing that I need to do is I need to find the k value for this function. And recall that k can be calculated as 360 degrees over the period, or if using radians, 2 pi over period. Well, the period we can see is 12.5, so the k value is going to be equal to 360 degrees over 12.5, and 360 degrees divided by 12.5 is equal to 28.8. So I now have the equation of the function because I have a, 4.4, k, 28.8, d, which is 0, since I'm starting at the maximum right here, and then I also have c, which is 5.6 right there. So depth as a function of time is equal to 4.4 cos 28.8 t, and then plus 5.6. So I have now created the sinusoidal function to model this situation, and I need to determine if the captain can exit safely at 6:30 p.m. Well, what is 6:30 with respect to this? Well, 6:30 would be 4.5 hours from 2 p.m., right? So if I think about that, this right here, 6:30 p.m. is the time difference between 6:30 and 2 p.m. is 4.5. So t is equal to 4.5. 4.5 hours from 2 p.m. gets me to 6:30 p.m. So d at 4.5 is equal to 4.4 cos 28.8 times 4.5 plus 5.6. And putting that all into my calculator yields approximately 2.8. So therefore, at 6:30 p.m., the depth is 2.8 meters. Can the ship captain exit safely? Well, in order to exit safely, it has to be 2 meters. Looks like it's 2.8 meters. So yes, the ship captain can exit safely.